Moving right along, Unit 2, trig angles. So this was, first question here is talking about central angle, and we're using formulas that are specific to theta being in radians. So this says find the measure in radians. I'm going to use a formula here that says S equals R theta. If I'm talking about arc length, I'm going to use S equals R theta. And in this problem, they're saying that we have a central angle that's in a circle with radius 4, so that's 4, is subtended, so that means that the arc on the outside of the circle is 6 meters, and I don't know theta. So S equals R theta, divide both sides by 4, you have theta equals 6 over 4, which is 3 halves, or 1.5. So let's say theta is 1.5 radians. If it's not in terms of pi, decimals are okay. So theta equals 1.5 radians. The second one, suppose you're using a winch with a radius of 2 to lift a windmill blade to be installed, which makes 8 revolutions. Okay, so we're talking about a speed in this problem. And it's important you recognize that this is a linear speed. This winch is pulling this rope, this windmill, up. So this rope is going up. That's a linear speed that's moving along the outside of this winch. So what I've got here is I need to use that formula. First of all, it's r theta, but I want the speed. So how much is it going over time? This would be the velocity is r theta over time. So now I know my formula. I need to figure out what's the radius of my winch. The radius is 2 feet. Theta is 8 revolutions is going to help me. If each revolution is 2 pi radians, then 8 revolutions will be 16 pi. So I've gone 16 pi radians over the course of some amount of time. So this is 16 pi, and then it's over 15 seconds. Now it's important we're careful with our units here. This is 2 feet in 15 seconds. 2 times 16 pi feet, 16 seconds. So now I have 32 pi over 15 seconds. It doesn't really specify what units it wants it in. It doesn't say miles per hour, so I'll just leave it in feet per second. And now this would be, I can figure out as a decimal, 32 pi divided by 15 is about 6.7 feet per second. So we're good. This windmill, as it moves up, is going about 6.7 feet per second. Let's do another one. Here we're trying to figure out how high this cloud cover is. So you can actually get kind of lucky in this problem. If you see it's a 45, 45, 90, then you know that this also has to be h. So this is the same distance. From here to here is the same distance as from here to the cloud cover. So that's going to make this a little bit easier. What I'm going to do is write an equation now that says if this is h, this is 600 minus h. So what I'm going to do is say that the tangent of 75, since I don't know anything about this hypotenuse, is h over 600 minus h. And then I'll have an equation here. It only has one variable, so I can solve this equation. It's a little bit tricky to solve. I'm going to need to multiply both sides by 600 minus h. And then I'm going to have to distribute. So this is 600 times the tangent of 75 minus h times the tangent of 75. Then I need to get all my h's on one side, so 600 tangent of 75, that'll be a gross decimal, equals h plus h times the tangent of 75. Now, this is combining like terms. This is 1 plus whatever the tangent of 75 is. So I'm going to factor out an h and say 1 plus the tangent of 75, and the left side still doesn't change. Now, if I want to get h by itself, I need to divide both sides by 1 plus the tangent of 75. And now I have h by itself. So h is, I'm going to get this as a decimal, 600 times the tangent of 75 divided by, sorry, right? Try it again. Divided by 1 plus, you guys use parentheses here, 1 plus the tangent of 75. And that will get me 473.21. 473.21 feet. So the question is asking, find the height of the cloud cover. The cloud cover is 473.21 feet in the air. Let's try another one. This one says, okay, law of sines can be used in the triangle cases when you're given. If you don't remember, law of sines is appropriate when you have angle, angle, side, which is equivalent to angle, side, angle. You always have both of those if you have one of them. And then the last one is side, side, angle. That's that bad word one we got to worry about. Law of cosines is good when you have side, angle, side, or you have side, side, side. So in this problem, we have angle, angle, side, which I can then very quickly say, I really have all three angles, because if I do 180 minus 74 minus 63, this has to be 43 degrees. So if you have angle, angle, side, you really have angle, side, angle as well. So if I have angle, side, angle, I'm doing law of sines. Law of sines is you pick a side, so let's label these. This is C, this is B, and that's little a. It's little a, which is 4.5, over the sine of angle A, 74. And that equals, let's find B first. Little b over the sine of angle B, which is 63 degrees. All I need to do is cross multiply 4.5 times the sine of 63, and then divide by the sine of 74, which is 4.17. So B is 4.17. Now I need to find side C, so I'll do the same thing. I'll say that 4.5 over the sine of 74 is side C over the sine of 43 degrees. So it's a very similar process when you're doing law of sines. This is 4.5 times the sine of 43, and then I'm going to divide by the sine of 74, which is 3.19. So C is 3.19. Now that I have all three sides, A, B, and C, and I have all the angles, I'm done. Completely solved. Completely solved triangle ABC with A, B, and C, all three sides. If it's all three sides, that means we're talking law of cosine. So I'm going to draw this and say it doesn't really matter what kind of scale it's using, but I know that the three sides are, I'll call this angle A, so that's 12. This is angle B, so across here is 27, and that's angle C, so it's 20. You can draw it pretty much however you want, but at the end of the day, you're going to have to use the law of cosines. And the law of cosines is the same for pretty much all three angles. Let's just say that a squared is b squared plus c squared minus 2bc cosine A. So if I want to find angle A, I need to plug in A, B, and C and isolate the cosine. So to find angle A, I'm going to say 12 squared plus b squared is, 12 squared equals, b squared is 27 squared plus c squared is 20 squared minus 2 times 27 times 20 times the cosine of A. So now it's all calculator work. I need to solve this equation. So I like to do this in two steps. I'm going to say 12 squared minus 27 squared minus 20 squared. So I'm getting these squares taken care of. That's negative 985. And I'm going to divide out this, so divide by negative 2 times 27 times 20. What I have by itself now is the cosine of A. So this is saying the cosine of A is, what was that, 0.912? Okay, so where does the cosine equal 0.912? Well, if you want to figure that out, you do inverse cosine of 0.912, and that'll give you 24.2 degrees. So A is 24.2 degrees. Now I have to repeat that process. I know angle A, but I have to repeat that process to get B or C. So I'll do the same thing with B, and B squared is almost the same formula. You just replace the A's and B's, switch A's and B's to AC cosine, not A, B. So I'm going to do the same thing. B squared is 27 squared equals A squared plus C squared. So 12 squared plus 20 squared minus 2, 12, 20, cosine, now it's angle B. So I do the same steps. I'm going to do 27 squared minus 12 squared minus 20 squared. Divide out the coefficient for cosine. Make sure you use parentheses for order of operations. 12 times 20. And then I need to find the inverse cosine of that, and that will give me my angle B. Inverse cosine is 112.7. B is 112.7. Now you could, so that's obtuse, but it doesn't matter. If I draw it, it's fine. You could do law of cosines to find the third angle, but that's probably overkill. If you know two angles, you can always find the third by subtracting from 180. So 24.2 minus 112.7, and this will give me my missing angle C, which is 43.1 degrees. And now I have all three angles and all three sides, so I'm done. Last thing for Unit 2 is converting angles to radians or radians to angles. So if it's angles to radians, you want to multiply by pi over 180. That way, whatever you have in degrees will cancel out with the degrees. So we're going to multiply by pi over 180, so times pi over 180, and you can use a calculator to help you reduce the fraction. 35 over 180, not that you need it, hopefully, but it's easy. Math, frac, and that'll be 7 over 36. So this is 7 pi over 36. You can do the same thing here, multiply by pi over 180, but 14 over 18 is 7 over 9, so this is negative 7 pi over 9. So if I say 7 pi over 36, that's 35 degrees, or negative 7 pi over 9 is negative 140 degrees. If I want to go the other way, you just flip the fraction. So now this is 180 over pi. So the pi will cancel out, and now you have 3 times 180 divided by 13, which is not going to reduce, so it's going to be 540 over 13. So it's 540 over 13, which is, as a decimal, about 41.54 degrees. We just had it there. Okay, so if you want the exact answer, it's 540 over 13, or you can round it to 41.54 degrees. 2 radians, normally when we talk about radians, we're talking about in terms of pi, but that's okay. You don't have to. You can just say this is 360 divided by pi, because 2 times 180. So 360 divided by pi is 114.59 degrees. And that's it for Unit 2.